Hello, hello. I hope this is online. Let me know if you can hear me. Right. So, this is Junichiro Horikawa, and this is a live stream for tutorial, Houdini tutorial, and this is 135th episode. And today I'm going to create a simple twisting vase using simple vex functions. So yeah, it's the things that it's rotating right now. What I'm gonna do today is pretty simple. Just try to model this shape procedurally using a bunch of parameters and vex code. So I think it's pretty simple. The it could be interesting to see how you could change the twisting angle based on the height of the height, but that's pretty much it. Other than that, it's pretty simple. You just need to I'm just going to create a really simple twisty vase here today. You could also change the radius of this vase based on the height. I mean, there are a lot of space where you can modify if you know how to code. So I'll just show you the basic idea how could this be done, and I'll finish this live for today. Probably take around 30 minutes to 1 hour to finish this if it goes smoothly. So before starting this, I'll show you briefly how this is going to be made. First thing I'll do is to make a points arrayed in spiral like this. Not just a simple spiral, but changing the axis for the rotations based on the height, which is going to make the output shape a little bit interesting. Then create a line out of those points, and in order to create a bridge in between the curve on the bottom and the top as a layer, what I'm gonna do is to create two duplicate curves of this single curve. One is this one and one is this one, but trimming a little bit of curve on both sides like this, and combine them to create a layer curve or contour curve in between these two similar curves. Then I'll just use the skin to create a surface, and that's pretty much it. Other than that, after this I'm just trimming some of the pieces to make it look like a vase. So that's pretty much it. I guess what you need to know in this step is just to see how you can create these spiral points, as well as how you could connect these two curves as to create a surface in between the curve as a layer. So that's pretty much it. And let me try to do this from scratch as always. Right. So first of all, I'm gonna create a geometry node. Then start with an attribute wrangle. I'm just going to use a detail wrangle to create the spiral points from scratch using just the code. I mean, you could always use things like spiral, or you could modify the line to make it look like a spiral, but I'll go this way. I guess anyway is fine. What I like about using detail or angle is that I can just control fully from scratch, so sometimes I prefer doing that. So let's create a spiral points. I think you can consider this as a basic of Vex, probably, because a lot of things that I'm going to write is pretty basic, I think. So hope you like it. Okay, first thing first, I am going to create, I'm going to determine how many points you want to have for this curve, for this spiral. Probably, since this is a spiral curve, I am going to define how many turns it's going to have. Like, so I'm going to create an integer value called turn as a parameter where you can control how many turns, how many spiral turns you can have, you would have. Okay, next I'm going to set a parameter how many points you could have for each turn, which could be defined as the resolutions of the spiral curve. So I'm gonna call this res as a term of resolutions. Okay, and for this one I'm going to make the maximum 200 in case I want to have high res curve. Okay, now next I would, in order to create a spiral curve, I would need a radius, so I'm gonna give a radius parameter. For now I'm just gonna set to something 0.3 or something like that. Okay, now let's by using these parameters, let's start creating a simple spiral without like modifying the radius or axis angles or anything. Just try to make a simple spiral curve. Now I realize that I need one more parameter, which is going to be the height of the spiral curve, so let's have that as well. Okay, there you go. And the height could be a little bit more bigger, could be from 0 to 10. Okay, now let's try to create a spiral curve based on those 4 parameters. Now turn and resolutions define how many points we're going to have for a single spiral curve. So let's use that for a number of loops, which is going to be turn multiplied by res, or you could have a nested loop, one for the turn, one for the resolutions. Okay, which is handy in some cases, because that in that case you know which curve, which point belongs to which turn, right? Okay, now let's create a position for the point, which is going to be used as the spiral curve points, control points. Now first thing first, the equations for x and z value, which is going to be the plane information, and for the height, which is a y coordinate, will be calculated differently. First of all, the height is pretty easy, so let's calculate that first. Height will be in between 0 to the maximum height, which is this parameter, based on which points are we looking for. So it will be better if we could convert the point number to a normalized value, which is in between 0 to 1. So let's do that first. I'm gonna call that normalized point number to t, which is going to be in between 0 to 1. And you can calculate that by first of all, you can divide this n, which is this based on the resolutions, which is in between 0 to res -1. So you can divide this by resolutions first and add with a I, which is going to be, so I stands for the turn, right? And this will be a decimal number or float number, which is in between 0 to 1 for each turn. So as a result, you get from, if we have 3 turns, then you have 0, 1, 2 for the I. Oops. And for each n, you are adding, if n is equal to 10, then you're adding 0.1 to this I. So it starts from 0, 0.1, 0.2, 0.3, and on the next turn, the I becomes 1 and becomes 0, so it starts again from 1, 1.1, 1.2, 1.3, and so on. So this will be used, the range of this value is in between 0 to I plus 1. Okay. So I can then divide this value by a turn, a maximum turn value. Okay. Now, actually, the maximum of this value is probably if turn is 3, then it will be something like 2.99, something like that, based on the divisions of the resolutions, the number of resolutions. So if you want to have as a final value for t, if you want to have a normalized value in between 0 to 1, then you cannot just divide it by turn, which is in this case 3. So if you divide 2.99 by 3, then you get 0.99 something, some value like that. So in order to have a 0 to 1 normalized value, you also have to subtract this turn by 1 divided by n, or no, res value, which will give you the which in this case will give you the final, the maximum value for this evaluation or equations. Then as a result, you get a value in between 0 to 1. Right? Let's test it out. So I'm going to convert y to height multiplied by t, which in result you get a value in between 0 to height if this is in between 0 to 1. Okay. Now let's try to use that as a height for the position. I'm gonna skip x and z for now. Just gonna set it to 0 and add it as a new point to this position. Hopefully I'll be having a bunch of points in the height position, and let's check the geometry spreadsheet to see what's the maximum height. It says 3.61, which is equal to this height, so looks correct. Then let's check what parameter changes what. So turn changes how many points we're going to have, how many turns we're going to have, how many divisions, for each layers, and the resolution is the resolutions for each layers. Radius, and it's not being used yet. Height, total height. Okay. Now next thing I would like to do is to create a spiral plane information, which is x and z. So let's do that. Basically, it's just a circular value. So what you need is a trigonometry using sine and cosine to define the x and y position, x and z position. So for the x, I'm going to use a cosine together with some angle, which I haven't defined yet, multiply by a radius. For z, you use sine for this angle, multiply by radius. Now, what I have to define is this angle here. Okay, so let's see how I can define this. Thing is, for each turn, I want to have 360-degree rotations. So for when I is equal to 0, you want to have 0 degrees. If I is 1, then you want to have 360 degrees and so on. So for each turn, for each n, you will going to have the same angle over and over again. Even if the I is equal to 1, or even if the I is equal to 2, the value you used in this nested loop for n will always be used as the same angle value. So that will always be used as a one turn angles. So what I just need to do is to normalize this n value from 0 to 1 and multiply by 360 degrees, which is pretty simple. You just need to calculate n divided by number of resolutions, multiply by pi, multiply by 2. Okay, now you can insert these x and z to the position. There you go. You now have a spiral point position, which you can now control with radius, resolutions, and turn. You see, if it's equal to 1, you only have 360 degrees turn. 2, you have 2 turn, and so on. Okay. Now, I will go back to this code later, but for now, what I would like to do next is to try to create a surface in between these curve. I mean, currently it's a point, so let's convert this into curve. Then try to create a layer, like a bubble, like as a minimal surface, like shape, in between the curve which is on the bottom and which is on the top. Okay, see how we do that. So I'm going to use an add node. Let's close this for now. Set it to polygon by group. We'll convert this into a connected curve, which at this moment it will be much easier using this spiral node, but later we're going to modify this with some custom code. So let's keep that in mind. Right. Now, after having this add node, what I'm like to do is to create these slope surface-like shape in between the curve on the bottom and the curve on the top. And in order to do this, what I thought will be easy is to create a cross-section curve in between those curves on the bottom and top, and loft it using node like poly loft or skin. Now I would prefer skin because you can control which points to be connected with which point. So let's think about using skin. And in order to use this, you would need a cross-section curve, which goes along these curve, which is on the bottom and which is on the top. Okay, and go running across the spiral curve. Okay, so let's think about how we could do this. Now, in order to do this, what I thought about is having a duplicate curve of this single spiral curve. In this case, you could just have two null node, one called curve 1, one called curve 2, and then shift the one of the curve position slightly upward or downward by the height of the layer, and then loft these curves together to create a skin surface. So that's what I thought about. But currently it works if you just move it upward or downward. But if you change the radius of this shape randomly, I mean custom wise based on the height positions, then just moving the curve wouldn't work. So what I am going to do is to for the first curve, I'm going to trim the the bottom first layer for the curve 1, okay, so which is somewhere around here, around for 360 degrees on the bottom. And on the right hand side, the curve 2, I'm going to trim out the top part, same one turn regions, which is around 360 degrees. And by doing that, you could keep the total number of points the same for curve 1 and curve 2, which enables you to use skin in some way to connect these curves together. Okay, it's my plan. So let's see if we could do that. So what I would like to do is to, for the curve 1, delete the one on the bottom, curve 2, delete on the top. So in order to do that, you could count the number of points for each layers, but I would choose a little bit easier way. I'm going back to the code and apply some point attribute to each point, which point belongs to which layers. So that I can just say delete layer 1 and delete the last layer, and that's it. So let's apply that attribute to the point after I create it. I'm going to apply a value called layer to newly created point here, and the layer number is this I value, which determines in which turn this point's being created. So it's pretty easy. Now let's check the layer value. So it goes from 0, 1, 2, 3, 4, like that. So that 0 is the one on the bottom, 4 is the one on the top. So just want to delete the one on the bottom, which is layer is equal to 0, and curve 2, I want to delete the one on the top, which in this case layer is equal to 4. Or you could also say the layer is equal to the value which is similar to this, related to this value, turn minus 1, right? So I can just use delete node here. For points, say layer is equal to 0. Now I can just remove the points on the bottom part for this curve, and for the second curve I can do a similar expression for the group. Instead of saying 0, I can copy this value turn paste it here, then say -1. And since this is a integer value, I'm going to change this to CHI, or it doesn't, I'll just say CH, so that I can use it with the equations. Hopefully this will delete the top part. Yep. Now I have one that's have layer 0 deleted and one that has last layer deleted. Now what I can do is to try to connect these curves together. Let's see what would happen if I just use scan at this moment. And yeah, it does create a layer surface, but this isn't so pretty yet. I might want to have some culling or some curve as a section, cross section to make it a bit more prettier. So maybe just using this skin might not be enough, but instead what I would like to do is to create these cross section curve as a arc like shape and use that to create a skinned network or revolved or shape. It's my plan. Okay, hello everybody, thank you for joining. Let me see, maybe somebody has a question. Concept of an array of points position and want to isolate the n1. To use it, I wrote v position equal to v near point near pos n, but it creates me an empty vector instead of fetching the one I want. I see. Is there? Well, I guess you cannot use a square bracket to the vector directly, but you have to have a array of point numbers to deal with it. I'll just show you a quick example. If I have a bunch of points, like for example in the line, let's see, like this, and let's say I am going to try to get that information using detail attribute. So first of all, I'm going to get the total number of points from the second input, then gonna use a loop, or maybe I'm just gonna use point wrangle here, or maybe not, since you are trying to get you have an array of point positions, right? Array of new point position, so you have an array of vectors, you're saying? You're writing like this, but I think you should write it like this if it's an array of vectors in order to access the vector items. Yeah, so let me know if that's the case. Okay, I'll come back later for that. Okay, so where was I? So I needed to create a cross-section curve turn, like an arc shape. So before using this scan, what I'm going to try to do is to first of all create a curve in between the top and the bottom curve, and then try to bend it or have some arc shape to each of the lines that's being connected, that's been created. So for that, I still could use skin, but let's try to do this. Let's try to create this cross-section curve using wrangle. In this case, I'm going to use point wrangle and try not to merge it before. So I'm going to connect curve 1 to this first input of point wrangle, then second input to the second curve to the second input. Now the important thing is that first curve and the second curve must have the same number of points to connect these together. In this case, it does, since each resolutions for each turn is fixed, so should always work. Now let's call this connection and try to create first of all just a line to make it simple. So since we're working with the curve 1 points, what I want to get is this corresponding curve 2 points based on the point number. So target point position is point something like that. Right? And the source point position is just at P itself. Yeah. So I would like to create a line between this one and this one, and later I would like to make it as a arc shape. So let's create a target point. Since we already have a source point which is coming from its first input, we don't need to add it again, but we just need the target points to the target positions, and then create a line between these. As a polyline, PT num and TPT. Okay, well that was simple. Now next thing I would like to do is to have bunch of points in between those curve, between of each line, and have some bending or arc between those 2 points. So to do that, we need how many points we want to have for each line. So let's define it as some parameter. Doesn't have to be that much, but let's say 10 for now. Okay, and let's calculate the loop. And then we do need to add the curve within, maybe after. Wait a minute. Let's just delete this for now, and here we need to calculate the positions in between starting point and end point. So let's do that. And as always, it will be better if we have a normalized value in between 0 to 1 within a for loop, which is handy to use. So in this case, you can just divide I by float number minus 1, which will give you a value in between 0 to 1. Okay. Now you can now calculate the position value in between start point to end point by using functions something like lerp, the start position, target position, and use t as a parameter. You could get a position information between those start and end, then try to add new point to this new positions instead of just adding a point to the end position. Okay, as a result you get bunch of points arrayed in between start point and an end point. Now you could connect these points as a polyline. So I'm going to create a empty polyline first before the for loop. Then add this newly created point to this primitive using add vertex And that's it. Okay. Now it's the, oops, let me save this just in case I lose the result. Okay. Now, next thing I would like to do is to create a arc-like shape, which in this case I could use any kind of method. I mean, I could use sine wave to create a simple arc-like shape, or I could also use a ramp parameter to customly control the shape, which could be also interesting. But I'll try with the sine wave first, which is pretty simple to implement. So for the sine wave, zero sine function can be controlled with the angle, and if you just want to have a mountain-like shape with the sine wave, then you just need a value in between 0 to 180 degrees as a angle parameter. So what we could do is to convert this t into a value in between 0 to 180 degrees to use it as an angle. So I'll just multiply t, which is in between 0 to 1, with pi, which is a radians value, which is correspond to 180 degrees. Then I can I can use this angle with the sine wave, which will give you value in between 0 to 1, but as a mountain-like shape. Then I can use this to control this new positions, okay, that I have right here. So in order to I do want to create an arc which goes inward, in this case toward the center. So let's create that vector value for each point, and then use that vector together with this sine wave height value to move those points. Okay, so to estimate the vector value, the easiest way you could do is to just use this point positions and project this into a 0, 0 line which stands on 0, 0, 0, a line that goes upward in y direction, and then just project this new position to this line. Then you could have a vector value which goes from the center to plane center to this new positions, which could be used as the vector value. And the easiest way is just to normalize this new position, which will give you a directional value, although this includes y value, so before normalizing it I might need to replace y with 0 so that it doesn't go upward or downward, then normalize it. Okay, normalizing the vector will give you a length of 1 for this vector, and finally if you multiply this by an r, which in this case a height of sine wave, you can now use this direction to move this new point position. Now you might also want to have some additional parameter to control the height of the wave, since sine always give you a value in between 0 to 1. So let's have float value called wave height, which you can control the actual moving direction, moving amount. Then finally you can update the new position with this direction and see what happens. Okay, so if it's positive, it goes outward. I think if it's negative, it goes inward. Both way looks interesting. Probably I want to go for negative as well, so let's change the range of this wave height from -1 to +1. Okay. Okay, now that looks good. Now after having these contours, I can just use, since each curve has same number of points, I believe, which is defined by this number of divisions, you can now use this skin to connect each cross-section curves together as a surface. Now I do seem to have some problem here, which might be due to, let me check. The reason is because I also have included this original spiral curve, which in this case I don't really anymore. I don't really need these anymore. So I do need to delete the original curve, which is this one. So to do that, I actually didn't really need it to make it as a curve, I think. So I can just use a point itself, still gives you the same result, still used with the skin. So maybe I didn't really need it to make it as a curve, spiral curve. Okay, now this seems to work. Now what I see here is this duplicated points on these sections. So if you could always fuse it to merge these points, which might going to make these edges a bit smoother if you normalize, if you put the normal with the point. So it's pretty up to you. If you don't want to have these smoothed surface when you put the normal, then you could avoid using fuse. Okay, still works. Now it's time to customize this thing a little bit more to make it procedural, a procedurally customizable, interesting shape. Okay, now this is the basic setup that I have right now. Now, well, what I would like to try out next is to, let's say, control the radius customly based on the height. So let's try to do that first. I'm gonna increase the number of turns and increase the resolutions, radius, and connection. For now, let's make it something like this, and I'm going to try to control the shape of this vase. Currently it just looks like a duct, so it doesn't look really interesting. So now what I want to do is to change this radius based on the height or any kind of information. I mean, height is pretty easy to understand in this case, since this is height oriented shape, but you could always use different values. Now you can relate the height with this t actually, because it's equally going upward. So I'm gonna use this t to control this radius, and t is currently in between 0 to 1, so I can actually update this radius, or create a temporal radius by using chramp parameter to use curve parameter to control the radius shape. So I'm going to say rad ramp for t, and then multiply it by the original radius. Can replace this with trad and trad. Okay, let's try to control this curve. Now it as a default value, it goes from 0 to 1 linear ramp, so we'll give you this shape. So y value stands for the radius and x value stands for the height from bottom to top. So if x is equal to 1 and if y is equal to 1, then you get the maximum radius. If y is equal to 0, then you get minimum radius. Now it's time to control this curve as much as you want. I'm going to convert this into B-spline however you want, like that. Okay, well, something like this. And you can also try changing those parameters to see the differences. Okay, that was pretty easy. I mean, that's for the radius. Still a manual operations, but yeah, still I would call it procedural. Now, next thing I could change for this process is to change the axis for this spiral rotation. Currently, the rotation of this point has been done using just the y-axis, but I could actually tilt this y-axis to some different direction to make this turn a little bit interesting, I think. Like tilt this spiral curve itself in some direction. So that's what I would like to try out. And currently I am not using any axis informations in order to create the point position. So instead of using cosine and sine, maybe I could use a transformation matrix to rotate, or I can still keep this default circular shape, just try to add additional rotational matrix to this points. Maybe that's easier. So let's do that. I have this point, final point for this spiral curve. So let's say I want to modify this point a little bit based on using rotational matrix, using tilted axis. So let's try that out. So the idea is, I'll just show you one idea. Let's say I have a matrix, identity matrix. Start with the identity matrix, which does nothing at this moment. Rotate this matrix by some small angle, like radians 15 degrees, and then using x-axis to rotate. Now I want to then rotate this point position with this rotational matrix, but not with having 0, 0, 0 as a rotational center, but I would like to use a rotation center for each point, which is going to be the projected point on a straight y line. So what I need to do is to create a center of the rotation next. The center of the rotation could be set as position.x, no, 0 position dot y 0, which is going to be the projected point position for each spiral point projected on the straight line going upward. Now that I have a pivot or rotational center, I can now subtract the final point position with the center, rotate with the rotational matrix, and add the center back again. See what happens. Now I can see that the geometry has been tilted a little bit using this angle. If I change this to 30 degrees, it's now tilting 30 degrees and so on. Okay. Now the problem is it's just tilting in the same directions at the moment, so what I would like to do next is to change this procedurally. Change this value by some equations, maybe based on the t or something. So what I could think of is to rotate this value itself using this t value. Okay. You could use either another matrix to rotate, or you could use a trigonometry like cosine and sine to rotate this angle. Since I already have t, and maybe it might be easier to use cosine and sine, so let's see what would happen. So I can add t, and not sure what's the right value for the rotation, so let's say 60 degrees, and do the same for this one. See what happens. Not much changes, so maybe I need a little bit more changes. So 360 degrees, and now I start to see some changes in the bottom. If you compare in the rotation tilt on the bottom and the top, you see some different tilt direction. So these value could be parameterized, I think. Let's do that. Let's have a parameter called tilt angle, which will be used as a maximum tilt angle. And instead of using radians, I can multiply it by pi. T multiplied by tilt angle multiplied by pi. Okay. And if I change this value, maybe I want to multiply by 2 as well for this one. Okay. So now I can control the tilt differences. And you can always increase this to have more interesting wave at ease. Right. It's pretty interesting, I think. And you could always combine with another ramp parameter to control this tilt angle, to make more customized. Now I think I would also want to control these angles as well. So let's do that. Let's have that as, actually this is the tilt angle, isn't it? And this is axis angle, tilt axis angle. So let's rename this tilt angle is gonna be used here. Oops. And another one is going to be called as tilt axis okay, and replace this one, tilt Okay, now we have two informations goal, which defines how much it turns, how much it tilts, and tilt axis, which controls where in which direction to tilt. Right, not bad, I guess. Now let's increase the range for tilt axis maximum to 10. Okay, getting getting interesting. And if you go to negative, what would happen? Yeah, I guess also negative direction also works, so maybe you could have a range in between -10 to 10, as well as this one, I guess, but I'll just keep it as it is. Okay, getting interesting. Right. So now that I have these curve profile, which looks okay. Next thing I would like to correct or update is how it makes the layer surface. Currently, it doesn't really look natural for the layer surface because it's just going toward the center line, and the vector direction is always going perpendicular to the center line. But I think it will be more natural if we have a surface going like this, right? Like that. So let's fix that. I mean, this itself might all be okay, but I don't really like it, so I want to fix that. So what I need to fix is this direction, where I have it here. So I'm going to comment this out and replace with direction which goes perpendicular to the direction goes from the bottom point to the top point, perpendicular to that direction. So somewhere this direction here. So to calculate that, you need several information. One is these vector value going from bottom to top, which you could definitely get it, which is these two position information. So first of all, I'll call this axis, going from S position to T position by subtracting two vectors. Normalize it. Now next I need to calculate the perpendicular vector which goes inward or outward, either way. So to do that, I could probably use a cross product together with a perpendicular vector value which goes sideways, the horizontal way. Which do I have that? Let's see. I am not sure if I have that information. Probably not, so I need to make either one of those informations. Okay. Well, I still have this direction which goes inward, so maybe I can use this as a guide to create a perpendicular value. Okay, meaning I can, if I calculate the dot cross product between this vector and the one that connects from start to end, start to target, and if I have a vector goes this way, I could get, if I use a cross product, then I can have a perpendicular vector value which is both perpendicular to this direction and this direction. So as a result, I think what I'm going to get out of these two vectors is a side perpendicular vector value. Then I can use that perpendicular vector value to recalculate the vector value which goes from this line to go perpendicular to this way, to inward. I don't know if that makes sense, but let's try. So if I have a direction, and let's forget about multiplying r, just normalize it, and then update direction by using cross product between the axis and direction, and then I can again use a cross product between which one and which one. Let's try cross product between again the axis and direction. See if it's gonna work. So I'm doing the same operation twice, but the result that I'm getting is different. Let's see. Oop. That looks too much. Well, in the end I need to multiply it by r to define how much it should move. Okay, now it looks like it's going outward, but the direction looks perpendicular, so it looks correct. Let's see if I make this positive. Okay, alright, now the direction of this layer layer arc seems correct. This one gives a smooth arc shape in between point 1 and point 2. Alright, that's good. Now another thing I would want to try is, based on the distance between the starting point and end point, maybe I might want to change how much it goes inward, how much is this arc height is, which is pretty easy to do. You just need to calculate this in the distance between start and end. Like this, start position and end position, and use this distance somehow together with this height of the wave. Okay, now it seems like this distance is less than 1, so it gives you small height for overall, so I might need to increase the wave height range a little bit more. Let's see what happens. Okay, so in this case, if the distance is higher, then the depths will also become higher. If the distance is smaller, then the depth also becomes smaller, which I think it makes sense if you think about like a slope like shape, surface, minimum surface. I think it does make sense. Yeah. I might also need to use some square root or square value for this distance to make it a bit more natural, but anyway, it seems to work. Alright, that looks good. And let's try out different values in even with the inflating method, it looks fine, like a croissant. Okay. Okay, so that is pretty much it. I think I've done all the stuff that I wanted to talk about today. In the end, you could always trim out the unnecessary points to make it like a vase. Currently, I have these, how do I say, trim or cut layer positions where I might want to trim out flat. Same as for these points. To do that, you could always use clip or boolean or any things you want. If you just want to clip with this point, but I guess it will still keep those surfaces. So let's see what happens. Clip and increase the range distance, so we'll go something like this. You might be able to define the minimum distance. Maybe in this case, I guess the minimum distance for this clip is somewhere around here, right? And for the top part will be somewhere around here. Okay, so you could probably estimate those positions procedurally by first thing first, fuse it and get the border geometry by divide, or yeah, I'll just use divide. Remove shared edges will give you two geometry, one on the bottom and one on the top. Okay, then what I would want to do next is to get, for the bottom part, I want to get the highest point position. For the top part, I want to get the lowest point positions. Okay, so I could first sort these two geometry by primitive y, split it into two. Now would I want to do this by wrangle? Maybe. I guess I could also do that. But if you just want to do a node way, I think I can just split the bottom and top and resort the point position. For the bottom part, I want to sort it by y as well as the top part, but either one of them will go reverse. So in this case, I want to get the highest point, so this one goes reversed and this one goes just as it is, from small to large. And I can get the first point of this sort to first point of this sort 3 to be used as a value for the clip position. Let's name it bottom. Top, and then refer to both point position in this clip. So for this case, I want to get the bottom point position, which is somewhere around here, I guess, and which is sorted out with this sort. So the value, the point number 0 is the one that is the highest. So we can get that information by changing this origin to the height of this 0. So point bottom 0 p 1. Just want to get the y value, so it's 1. Okay, as a result, it's been trimmed with the position where I want it. Okay, next for the top. For the top part, I want to trim and this point, I think. This is the lowest. So I give another clip. In this case, the direction is -1 and the point position is top. And that's it. It's not that clean, it's not so clean, but it does what it does. Okay, so that's how we could do it. And now, as a final touch, maybe I can match size to place this on the floor. Justify y to minimum, yeah, which then make this vase sits on the floor. Okay, so that's pretty much it. Now I control a bunch of shape using tilt angle, first of all a number of turn, I think I need to increase the range here, something like 50. I have turn, I have resolutions, which is not important, radius, maximum radius, height, shape, and tilt angle, as well as tilt axis changes. And going back to connection, you could also control the arc. This resolutions, this is where you can control. I think there's a lot of space here where you can have more control over in many ways. I mean, you could also control how it change the height, how it changes the depths of these arc, maybe based on the height or based on any or some attractors from outside. And that's pretty much it. Yeah. Okay, so let me check comments if you guys have any questions. Hello Junichiro, have you ever thought about making a knot generator for rope wires, knot generators through a vellum sim? Sounds interesting. Yeah, I would love that. Will it be with UV? Currently it doesn't have UV, so yeah, probably a good idea to apply UV to this one. I'll do that. Procedural 3D is a complex field. Placing smoothing. How are you going to make a clean top in this even possible? Yeah, currently it's not really clean for this top, so let's think. Let's first apply UV and let's think how we could make the clean top. I mean, I could always have the last turn to be connected with here, so you have a modified spiral curve which goes from somewhere around here to end with this point. So that's one thing I could do, same for the starting point. So maybe that's what I could do as a modification. So shall we do that? Okay, so let's make the shape simple for now. so that it'll be easy to see the changes. So first thing first, let's see how we could set the UV. So obviously this is the strip shape, so setting UV will be maybe this cross-section curve will be U and the spiral curve direction will be V. I think that makes sense. So let me do that way. I think skin will preserve the curve point attribute, which was in this cross-section curve. So I could apply a UV information to this cross-section curve, and then hopefully the skin will preserve it to use it as a UV. So let's go back to connection and see where I can fix. Okay, so so we have the V. I want to use V as a spiral curve direction, and U as a cross-section curve direction. And cross-section information can be this T value, which is a normalized value, for the cross-section curve. Start point will be 0, end point will be 1, so you can just use it as it is, as a U value, U for the UV. So let's create that somewhere around here. Float U is just the T itself. Now for the V, you can just divide the current point number by the total point number of this curve coming from this curve 1. So in this case you have a total of 975, so if you just divide the point number by that length, you just get 0 to 1 based on the spiral curve direction. So that will be easy. And in case you want to have a value in between 0 to 1, you want to subtract by 1 because this starts from 0. Okay, so this will give you U and V. Now make it as a vector value and set it to point as an attribute. See what happens. Okay, I think it works. It's been skewed a lot. I mean, it's been stretched a lot because the spiral curve length is pretty long. If you want to have a repeated UV, then you could always multiply this V value by, I don't know, maybe a number of layers and so on. In this case, each point has a layer number, so you can say V plus F E at layer. Did it make changes? Nope, I don't think so. Let me see. Okay, I think after I have that doesn't work. I kind of have to multiply this by a total number of layers, I think. So I think I would need access to the total number of layers, so let's have that as a parameter. Which is accessible here, which is available here, a number of turns. Let's copy that and paste it here. Now since I am deleting one of the layers with this delete, it has to be this current layer -1 to turn number -1. So I am going to multiply V by layer -1. Let's see what happens. There you go. You're going to have 0 to 1 UV for each turn, which might make sense if you want to have a repeated pattern for each layers. If not, you can remove this and set it to 0 to 1. Okay, so that's that. So that's for the UV, and in order to merge the last point to here, probably I need to go back to the original spiral curve here where I am creating the spiral curve itself. So let's compare this one with this one. Alright, so let's see how I can do that. So you just need to look for the first layer and the last layer, which you can define by in which loop you're in right now. So if I is equal to 0, then you're in the first loop. If I is in the last turn -1, then you're in the last loop. And that's where you want to modify the spiral to have the point being merged to the next loop's endpoint. Okay. So shall we do that? Okay. In order to do that, let's see. Let me check the final geometry as well. I'm gonna try with the first loop before trimming out. Okay. So basically, from this point to this point is one loop. Okay. And what I would like to do is to move this starting point to here. Okay, each point to these positions slightly slightly. Okay, so let's see. Might not be straightforward, but I could try that. So this is where we have final point positions here. And this is where we are adding the point as a point position. Now we do need to modify this point positions for if the layer is equal to 1. Okay. So let's do that. And in order to do that, we kind of need to know the goal for this first point, which in which direction this point has to go as a goal. So I think I need to calculate this previously, then reuse it in another loop, I think, if that makes sense. Yeah, I think. So let me do that by creating a point position array and add this final position to the array, and then prevent adding point at this point at this moment yet. Okay, and to give another loop, I shouldn't use I, but I should use N. Going to be the same length, and access to the point position from the positions array. Do the same operations that I have here. Let's check if this is gonna work. I mean, I haven't fixed the connection part yet, but gonna make sure this works for the other curves. Okay, it works now. Now that I already have a position array, I can access to the current point arrays, how it's being arrayed for each layers. So if layer is equal to I is the number of layers. So if I is equal to 0, which means if it's on the first loop, if it's on the first layer, then I can have another position as a target position. Do we have that tpos variable? Other? Okay, I guess I can use tpos. The other tpos, so for this source point, the target position should be this point. For the next point, the corresponding target point should be this point. So counting from the last point. So I'm going to use the same positions, but counting from the last. So the total number of positions minus n will be counting from the last. Okay, so this is the current position, starting from here, going till the end. But for this one, starting from here, go back to here. And now, now that I have these information, I can then lerp between these 2 points together to have a final point position. Yeah, so let's see. Final point position, I can use something like lerp, and I still need to have a normalized value for at this n. So I'm going to divide n by float resolutions minus 1. Okay, right, then I'm gonna use that t inside here. So if the t is equal to 0, then I'm gonna move this point to tpos. So tpos comes this first, and then current position comes second. And then if I enter this t here, then what would happen? Might not what I want, but let's see. Might not be what I want. I think I need to modify this t a little. But let's see. Actually, here I need to just update this position. Okay. So not so much that I want it. Let's go back to see what it should look like. So first of all, I want to make sure that this one goes here. So I'm gonna set it to 0 for now, see what happens. In this case, every points will go to this point, I believe, isn't it? That's what would happen, right? I'm not sure if that's what's happening here, but I think it is. Yeah. So next, I think I need to control this t value in order to have slightly goes toward these positions. So goes from t position to right. Now let me think. So lerp going from right here to actually let's say I wanna start moving this point from where? The middle of the curve. From here, change this to this position. Yeah. So in this case, in these cases, I need to define, need to define this t value somehow. This should not be a position, but the one that's in the middle in between t-pos and pos, right? Not sure if that's makes sense, but let's try. Let's see if this is gonna work. Just trying out. And no, still not good. Okay, this doesn't look good. Maybe I'm missing something here. Yeah, I don't think it looks good at all. Let me think again. So, let's go back to this spiral curve itself and see what happens. Position is equal to lerp t pos t pos. Wait, if I just make this to t pos, then what would happen? Wait, nothing seems to happen. But then, yeah, I have some problem here. Okay, well, this point's supposed to move and doesn't, so maybe I'm doing something wrong. Let me see. I'm going to get the target position. What was it? Length of positions -1. No, minus n. Oh, wait a minute. I think I need to do -1 as well. I think that's what I was missing. Then nope, still not. Wait a minute. Okay, it's just right. Actually, if I just do this, okay, I see now what was wrong. Okay. So and if layer is equal to 0, no, not the layer, but I. Okay. Okay, starting to understand what's going on here. Right, now lerp t-pos position t, and this is where I did wrong. I think I need to do something like this. Okay, now I can then subtract this by n. It's close. It's pretty close. Let's see what would happen with these. If I make a skin. Eesh. Not there yet. Not there yet. This is close, but let me think in a sketch. So I have a curve like that. What I want to do is to just move this point to here. I mean, sometime it goes like this, so just want to move these points so that in the end the curve will be something like that, I guess. Yeah. So each point has to move as well a little bit. Okay, and probably is a smoothed value going from each point to the goal point. So this is where it's gonna be difficult. How am I going to estimate other points direction, how much it should move? Right, that'll be the question, I guess. And it makes difficult because I have a custom radius and custom tilt. That makes the problem a bit hard to think. If it's just a straight spiral, will be much easier. But that's gonna make a geometry boring, but so I want to solve with these shape. So I think it's easier to go from the top first, so I'll try to do with the top geometry first. Okay, so if I is equal to term -1, then each point stay for some time. From here, I slowly want to move this close to these points. So maybe this is not really what I want, but what I want is the one which is one layer behind. The point informations for the one layer behind. So that those information will be necessary in order to snap to these points smoothly. Okay, I think that makes sense. So this is wrong, but I do need another layer, which I don't have it right now. So how would I get it? I think I have to go to the other layer first. I have to make another layer first in order to do that. What I can do is to have these information together with the turn information as an array or dictionary, then go back to another loop. Yeah, maybe that's what I need to do. Okay, shall we do that? Shall we do that? I think I can do that. So what I just need to do is to move this outside the whole loop, then move this outside the loop. Oops. Okay, and then I just need a single loop, but instead of iterate through the resolutions, I'm going to iterate through these positions instead. Okay, so I is equal to 0, I length of positions, and I. Then I can still create a normalized value, which in this case are ren positions. Alright. Okay, and I can estimate the current layer, which is by dividing I by a number of number of resolutions. So I by resolutions, and then calculate the floor, which will give you a layer value, I think. Okay. And get the positions. I think I can still get the same value here. Oop, no, but I don't get the skin geometry. That is because I have to add this layer value, and which is not I, but instead I have to give layer. Okay. And yeah, so give the same result. So now it'll be possible for each turn, each points to get the previous layer values. Yeah. So if I is the last, if we are in the last layer, which is turn -1, that's fine. Then what we want to have is the target position, which is the one before this current layer. So I is equal to turn -2. Okay, and that position can be estimated or get it by turn -2 multiply by resolution plus I. Yeah. Okay, so this one and this one should be corresponding to each other. If this is the position, then this is the t-pos. If this is the position, this is the t-pos, and so on. Let's see if that's the case. I can check it by just connecting the line. I can have the point first, and temporarily gonna create a point to this t-pos to see if I'm getting the right value. Think I am having some mistakes on the code. Invalid source, no matching function, add prim. Okay. Oop, This has to be integer. And oop, I think I'm doing something wrong here. Why am I having these? Oh, wait a minute. This has to be a layer. Okay. Now, am I getting those line information? No. I don't think so. Let's see. I mean, it has to be created right here. Okay, it's wrong. Every point's being connected to a 0, 0, 0, which is obviously wrong. So, that case, why is that? Maybe this t-pos is wrong. Let's check. Yeah. So this t position is wrong for some reasons. So turn 2, this is the number of layer. Hopefully I hope this will be the last second layer. And multiply by resolutions, added by I. No, why I? No, this is wrong. I shouldn't add I to this. Yeah, actually, I can just say I minus resolutions and that's it. Yeah, that was easy. Okay. Right. So this seems correct. I can now remove this and remove this as well. Make this back somewhere around here. Now what I need to do next is to lerp between position and t-pos to smoothly connect from, so that this will be connected somewhere around here. Okay, I think this is going to work. Position is equal to lerp from position to t-pos, and if it's equal to 1, did it work? Not sure. Maybe not. It's just t. So if t is equal to 0, then the position is going to be used, and I might need to use power or something to this t. Yeah, getting a little bit. Probably not. Not what I wanted. Let's just see how it looks like when I use skin. Okay, it's not what I wanted. Why am I having this here? T-pos, position to T-pos. Okay, let me cancel this. Okay, so starting from somewhere around here, and gradually I want to move these points to the target, and I think that's what I wanted to do. But it's not doing what I want. Let me me see. The way okay, again, the way I calculate t is wrong. It has to be based on the resolution value. So okay, this is floor t is I modulus resolution divided by or divided by resolution minus 1. Okay, yeah, I think this is it. And let me check the skin again. And there you go. Much better. Okay. That's what I wanted to have. Now you could still use power to this T, see what happens. Yup. Nice. I mean, you can have this as a parameter then. How to connect the end. Now that's for the end. That's for the end, so you need to do for the layer 0 as well. Which is here. Pretty much the same idea, I think. But in this case, this is not one before, but one after. So, which it needs to refer to. So, else if layer is equal to 0, vector tpos is equal to positions I plus res. Now, let's see. Position is equal to lerp. Position tpos. In this case, I could still use power function, but instead of just using t, I think I need to subtract t by 1. I think. Let me check. There you go. Alright. Well, it's tilted. It's not flat, so if you still need a flat, then you still need to clip it, but at least it's smoothly connected. And yeah, looks nice, I think. Yeah, so hopefully this is what you were asking for, but this is what I would approach. Okay, and finally, I mean, maybe you don't really need a clip anymore. Maybe you still would need a clip for the bottom if you want to have a flat face, but at least for the top you wouldn't need it anymore. That doesn't really look clean on the bottom as well. Well, I mean, you could always disable it. Okay. So I guess that's pretty much it, what I wanted to show. I could now gather all the parameters that I have all over to one place and then finish this live stream. Okay, I'll just copy a bunch of parameters that I set manually. Turn, resolution, radius, height, ramp, tilt angle, tilt axis, power. So let's rename this number of turns, res per turn, maximum radius, and the ramp rad, or I can say shape ramp. Let me know if you guys have any other questions based on these. The height, total height, tilt, spiral tilt angle, spiral tilt axis, spiral tilt axis, and connection smoothness, I guess. And I should call that number of spiral turn. Res per spiral turn. Okay, I think I have other parameters, which is, what's this? I don't really need to parameterize this one, which is just the resolutions. Maybe I could still do that. Res for layer, guess, and wave height, layer wave height. Okay. What else? Skin is automatic, normal, yeah, everything else is automatic, I guess. Okay, so that's pretty much it. I can probably use clean to remove unnecessary points if I have it. Okay. Yep. Should do it. Only joined very recently, so have no questions, but very nifty design still. Thanks for all the comments. Okay, so I guess there are no questions, so I'll just end the live somewhere probably around here. So I have, as a result, I have these shape. You can change the number of turns, spiral turns, the resolution for the turn, maximum radius, the shape of the vase, and what else? Total height, spiral tilt angle, as well as the axis for the tilt. End connection smoothness, which is for these ends. Probably better go above 1, so I'll make this range from 1 to 10, I guess. Yeah, I'll go with 10. I'll go with 2 for now. And then resolutions for the layer, it's not it's how many numbers you have divisions in these cross sections, and wave height, also the direction. It's like this is also interesting, isn't it? More like a cork screw shape. It doesn't really look like a vase anymore, but I still like it. And that's it. Maybe I can add another node, whether you want to use clip or not. So for the bottom shape. So I'll give a toggle, go bottom flat bottom, copy this parameter and set it to switch. So if you need, right now this is tilted, but if you need a flat bottom, then you can check this and make it flat. Okay, that'll do. Okay, so this is it. Thank you very much for watching. Hope you liked it. As always, I'm going to upload the files to Patreon page, which is free to browse. So if you're interested, please go back to the description page for the page URL. I'll post it later. And if you like this kind of stuff, then if you could support me on Patreon, then that would also be great. Only if you wish to. So that's it. Thank you very much for watching. Hopefully I'll be able to do something next week as well. Yeah, sometime. Okay, that's it. Thank you very much and good night. I come back to the video page so that I will post the URL where you can download this file that I created on this live. Night, good night everybody, and see you sometime. I can now rotate this. Nice. Yep. Good night. You sound like Daniel Tiger. I'm sorry, I don't know him. Okay, well, thank you for coming. Good night.